Okay, so hello everyone. Welcome again for the newcomers here in this room. Today we have Martin that will talk about Solara and how to scale data apps with a pure Python React style code. So Martin, floor is yours.
Yeah. So my name is Maarten Breddels, and as he said, I'm going to talk about Solara. So maybe you're wondering, why am I presenting this work? I am a ipy widget maintainer, which means that I deeply care about this project, want this to succeed, and want to improve the whole ecosystem. I've also co-created with Sylvain Collet the Voila library for exposing ipy widgets to non-technical users, and ipywidgets-based and Voila Vutify together with Mario Buikhuizen to create beautiful web interfaces for non-technical users that start in the Jupyter Notebook. We've done this with many organizations and companies to basically build prototypes in Notebook and build them towards production using for the GLUE project, Domino Data Lab. Space Telescope has with a strong focus on scientific exploration in the Notebook, and Oslar, for instance, in an internal organization data app that started in also in the Notebook. So we've been doing this successfully for a few years, and now we started our company, Widgety, and kind of our vision is, in a lot of cases, people start with a small prototype in the Jupyter Notebook, like single user, really small app, but they want to grow to the upper right corner. Like the app, they want to grow the app in complexity, like more features, and to want to expose this internally, often internally to many more users. So we want to go to this upper right corner. And we want to make this as smooth as possible. So we don't want to end up like this grumpy cat, frustrated, but we want to feel more like this cat. It's kind of our mission. So for this talk, I'm going to make a small app in a notebook, discuss what the issues are, and then we're going to get to this promised land where this cat is in 2 steps. We're going to handle or discuss something about code complexity, so we're going to redo our app a bit. I'm going to discuss slightly on performance. I'll give you some real code, real examples that are like running now, so to show that this is really like production ready, and I'll recap in the end. So those of you who've seen a talk of me before, this is my lucky slide, and it always works. So imagine we're going to create a small app. We have some photos of blood, and we want to count the red and blood cells because we want to create like a training set for some machine learning algorithms. That's interesting. Some cells were removed. Okay, we're going to read in the file path, and we want to create some kind of UI. We don't, if we want like our colleagues to do something like this, we don't want them to present them like a Python interface. So we want to create maybe first like a drop down to select which image to select. And using ipywidget, we can change this in the front end and then print out what the value is on the back end. So this already shows you a little bit of interactive work with just a few lines. And then we can visualize this image using the image widget. So, okay, so now we could use Voila. Here I'm showing this integrated, but this could be shown using Voila for non-technical users. They would see only like this part, but it's not functional. If I change this, it doesn't rerun the notebook, so we need to do some event handling here. So already prepared something like this, where you respond to when the drop-down is changing, and then we update the image. So now, actually, if I change this, it does update the image. So this is already getting like a really simple UI for a non-technical user. But we want to count the types of blood cells, so we want to have some kind of like maybe a button that we click. So already prepared some code for that. So we create a button, we have an on-click handler, we have an initial label here, and if we click it, we update the label. Maybe already a bit of code smell, this code duplication here. But there's a bug now. So if I count number of, so let's like I count 6, okay, I go on to the next one. And still the counter is at 6. So we introduced a bug here. So every time that the image changes, we need to update not only our global variable, another code smell, but also the description of the button. Okay, so now we fix this bug, but now the next problem comes. It's like, okay, we have this one button for the red ones. Do we like copy paste our code, or how can we reuse this code for like a different type of blood cell? So what's the current situation? So it's really easy to get started with ipywidget, just a single line, and you have like a drop down, you add event handlers, etc. But there are two issues here. First, there's not really a clear path forward for making reusable components. Like I cannot reuse this button that I created for a different type of blood cell. But also we introduced something called incidental code complexity, and I'll skip the part about autocomplete and type safety. So let's dive into like what's going on here. So why does this incidental complexity arise? So every time you add a feature, you usually add state. So in this case, the value of this dropdown is a state value, and we introduced one button, which is another state value. But for every state transition, so if I click on the button or I change the dropdown, you have state transitions. So you need to like respond in the event handlers. And as you can see, we needed to not only update the count if you click on the button, but also the description. And in the other event handler, we also needed both. So this is kind of a quadratic complexity. So you can imagine having 10 states, 10 UI components, like it's a lot of manual bookkeeping. This usually goes wrong. There are more reasons, but I think this is the most easy one to grasp. So this results in this grumpy cat. I mean, it's really frustrating if you just introduce every new feature introduces a new bug, and in the end you just like want to give up. Like, hey, I don't want to work on this project anymore. So project velocity goes down. And projects can fail because of that. So we wanted to fix this, but just not a little bit better, but we really want to improve this in the best possible way. So how do we get to this vision? So with Voila, we could already like get from a notebook to more users, more like non-technical users. But it didn't help us in conquering code complexity. So we want to have a tool to go to the right to make like larger, more complex apps. And if we have that, we can again use Voila to present it to our non-technical user. And then later on, I'll talk a bit more about the better performance. So let's talk about how do we conquer this code complexity. So maybe I should create a new paradigm. Well, if I say new, I always think about this XKCD where there are like 14 competing standards, so probably need to have like a new standard, and then there are like 15, and it's not like better. So I always have this for many situations, like, okay, let's not create something new. But the bigger problem, I think, is like if I have a new paradigm, would you trust it? Like, would you go out the door and think like, okay, I can sell this to my manager or director, and this is going to work? So who's actually building UIs in the world? And that's actually the JavaScript community. They're building a lot of UIs. And the biggest websites are basically, or apps are built using React, Vue, and Svelte. And actually React is something that is really easy to translate to Python because there's no like HTML markup. It's just like code. So this is really a candidate that translates well to Python. The way I think about React is the main feature, it's declarative. So our view is a function of the state. So you put in data and a view comes out. And it's proven technology for 10 years. I mean, a lot has been built using React, and it's basically been proven to work. And people trust that it really solves problems. And something I didn't anticipate when I started this is because it looks like React, it kind of a Copilot kind of like understands what you're doing. So with that, I want to introduce you the new tool called Solara, which is a React-like API for ipywidgets. So it's a declarative, which in my opinion reduces bugs quite a bit. You can create reusable UI components. It's inspired on React.js, so JavaScript, but it's 100% Python. So the underlying library called Reacton is pure Python. Provides many components such as like buttons, sliders, file downloads, things like for displaying data frames, but it reuses the whole ipywidget ecosystem. So we're not building something from scratch, we're building on top. And on top of that, not just components, but we solve a lot of like common challenges also in the like data science world, like an easy way to do threading, cross-filtering, caching, etc. And we have a nice way of doing type-safe state management, which I'll show in the second demo. So let's redo this app using Solara. So we read in the images, we import Solara, and instead of having our like state in the UI, we can separate from our UI. Like in the beginning, we declare what our state are: the image, the counts of the red and the white blood cells. And these are basically containers for a particular value, not so special. And a function, basically my simplest business logic function to reset the counts when I change my the image that I selected. Okay. So let's create our first component. It starts with the decorator. The casing is as similar to a class because it behaves more like a class. We have a drop-down, a select widget that controls this reactive variable, which image we selected. You can choose from the set of available images, and it will call this function if it changes. And it shows the image. And now I don't need to manually add an event handler if I change the drop-down. Actually, if the select changes the image, this component re-renders itself. So you don't have to do like this manual bookkeeping. This will re-execute and update the UI for you. Okay, so now we have one component. This button that we click on, can we make this reusable? Yes. So we have make a new component. That's basically a button which shows how many times you clicked, and an event handler that updates this reactive variable, and then it will like redraw itself. Like again, the issues that we saw in the other example are basically non-existing here. Just to show you that it works, let's get rid of it, and let's put this together in a single component with a nice card around it with a label, our previous component, the image selector, and the two buttons. So now we can actually count, and the previous bug that we had just isn't here. It's much easier to create something without bugs. And because it's built on top of ipywidgets, we can just use voila, so the same stack as before using this new layer on top. I just want to prime you, something that happens a lot is that if you, in this app, you read in some large data file, is that every time voila renders a page, it needs to like execute all the cells, so it will take about like 1-2 seconds to execute this first cell. Just to prime you, like one of the issues with voila. Okay, where are we? So we're halfway there. So we conquered complexity using Solara, or the UI part of Solara. We did this using a React-like API. The result is that we're like way more productive, happier, I hope. And we can use Voila to like show this to non-technical user, but I want to talk about like the server part of Solara, which is really useful for getting like a much better performance. So does it actually matter? I would say it's for user experience. If an app loads fast, that's like much more pleasant to work with. Sometimes hardware costs can be important. Depends, of course, what the budget is, but also the lower operational complexity. It's like if you can just run it on a single node, it's much easier than having to set up a full Kubernetes cluster. So what is Solara Server? It's a server that runs on standard Starlet FastAPI. Versus like Voila, it runs a single process. So Voila creates one kernel, which is one process for each request, and here we only have a single process. That leads to no process startup, no import times. You can share your data, so you only have to read like a file once. But also the Voila preheated kernels might be a solution, something to look into. We use something called a virtual kernel, so we don't create like a new process. We kind of like make a virtual kernel for every user, and we render a single widget. So we can execute a notebook. I'll show you now, but we're not showing all the cells, just a single widget. So how do you use it? Solara run, then the script name, so it can be a Python file, and then the component name, or like a notebook. So I'll show you here. So you do Solara run, and then the component name, we called it page for the like full. And now it's reading in the file once, the like slow startup time that we had in Voila, but now every like page refresh is like instant. So every new user instantly gets to see this app. Okay, so how does it work like graphically? So on the right you have the more like Jupyter way of doing things, like what also happens with Voila. Single request, so you enter an address, you load your page, and it actually spins up a single process, starts up Python, reads in data, doing all the imports. It can be quite slow. While in Solara, actually we have a single process that creates virtual kernels, and they can share all the memory, all the initialization, the modules, etc. Maybe you're thinking like, okay, this can be slow because of the GIL. You can use something like Unicorn and then have multiple workers working here. So actually the number of users and the number of processes scale independently. So is someone using this? Is this production ready? So actually the kind of showcase for Solara is the Solara website itself. Like the documentation runs on the Solara server itself, just to show like you can build like pretty large things with it. We did a large project with Domino called Domino Code Assist, which is like an app in the Jupyter Notebook to create a small like notebooks for data analysis, but also deploy apps. I think this is like the more, it's not open source, but it's the more like the largest code base that we know of using Solara. And there's a company from here from Swiss actually, Planito, that's working on like energy transition and planning, that started from a Jupyter Notebook to show like, hey, we have this prototype, we can like make an app out of this. And instead of having to rewrite all of this in like front end, back end, they're now using Solara to present this to their customers. Okay, so recap of our journey. We went to the right, using Solara to conquer code complexity. And we can still use Voila. So if you're already using ipywidgets with Voila, you can basically use only the UI part to make like larger apps. And for the better performance, you can switch over to Solara Server if necessary. So awesome. Hopefully I convince you that Solara, in my opinion, is the best Python web framework for really like a more larger, more complex apps. On the Solara website, you can try out the tutorial. Feel free to give us feedback. Giving us a star on GitHub also helps. I'm actually on vacation, just coming here today. So if you want to talk to me today or reach out to me using these channels. And also feel free to join Discord. You can find the link on the Solara website. That's it. Thank you.
Thank you very much for this great presentation. Time for questions. Thank you.
Thank you. All right. Thank you very much for your talk. Could you elaborate a little bit more on how the virtual kernels in Solara server works? Especially because you say that all imports and all initialization is only done once in that case, or how do you separate different users' processes in that case and do it securely?
Yeah, good question. Let's take this example, like this notebook. We execute this once. So all this code is being executed once, and we look for this component. And so for each user that connects, we execute this component, create like a new context. So every user has its own thread, and everything that is usually we have to, for instance, monkey patch some things that expect globals to be there and make them behave like thread local variables. You asked about security, or yeah, it is. I mean, it's a single process. So if you write something, for instance, using matplotlib, and you're using the non-object-oriented API, then you use a global shared figure, for instance. If you do that, that works fine in Voila, but with Solara, you can actually have someone else see what you're painting, etc. Streamlit had a similar issue. So you have to be you have to be aware that you're sharing the same process. So not write to globals, except these variables. These are actually also scoped. So they feel like you're writing to a global variable, but they're actually the value inside are scoped to that particular user.
Next question. Thank you.
Thanks for the talk, Martin. It was actually just a question, does Solara give you anything to help with state management as well? So for example, in that page that you wrapped up those two widgets, how would you recover red and white blood count per image?
Yeah, so actually red or per?
Like you put a counter per test image for red and white. And if you were doing a React app, you might have a Redux store with like a tree to do that. Does Solara give you anything to help with state management?
Yeah, so that's basically these reactive variables. So these are pretty simple. These are basically integer strings, etc. But you can put we support Pydantic and others. You can put larger objects in it, but only link a particular widget to a particular view of that larger object. So it's basically, we've looked at all the state management there. Like Redux, I think, is a bit overkill. People are moving towards simpler tools, like in the JavaScript world. Toestand is something we looked at, and this is a bit modeled like Toestand. But for the user, it's quite simple, but it's quite powerful in state management. And it's also possible, for instance, this is now linked to the UI, but also outside of the UI, you can access these variables. I hope that answers your question a bit.
Some other questions? If not, maybe I will abuse my host possibilities just to ask a short question. Is there any user access management on top of Solara, or we need to manage it ourselves, like integration with Active Directory, or even like some kind of user login and privileges on top of it?
I would say those are responsibilities of the person writing the app. We do have I didn't talk about that, but the Solara Enterprise version where we have some integration to OAuth tools. So that's really that simple to use, and then you can basically in your code on a like per component basis choose to like not show particular things. Also on our Solara website, like solara.dev, we have some examples on like if you go, connection is a bit slow. I think here we have some authorization example on how to do this. But it's not the full responsibility of Solara, but it's we're just providing examples and some integration on with OAuth. Yeah, good question.
Okay, thank you very much, Martin. Applause. Thank you.